In this video, I'm going to show you the connection between trigonometric substitution and high school trigonometry. So let's say you've got a circle of radius 1. So you've got a circle of radius 1. Rearrange this to make y the subject. So take away x squared. And then when you square root, you will get the positive version and the negative version. This is the positive version. This is the negative version. We don't care about the negative. So let's just consider the positive. So let's just look at this thing here. So we are interested in the area from 0 to a, from 0 to a. So it's really us integrating this. So trigonometric substitution. Our normal routine would be to zoom into this bit, create a triangle in such a way that this block will be true. So if we make the hypotenuse to be 1, the opposite to be x, then the adjacent will have no choice but to be square root 1 minus x squared. So we need to extract dx. So let's look at, so this is sine. So sine theta equals opposite over hypotenuse, opposite over hypotenuse. And then from here, differentiate it. That will then give us dx equals this thing here. So we can put this block into the dx. And then we need to extract this from the diagram. So looking at the diagram, you can see that that cos, this is cos, so cos the angle equals adjacent over hypotenuse, So we can put this into this block here. Okay, so when you put this into here, that will then give you this. So now tidy this up, so that becomes cos squared. So now it's just a matter of integrating cos squared. Now use whichever method you want. I'm just going to use the reduction formula. So using the reduction formula on this would then take you to here, and then if you integrate this, that will then take you to here. But you don't have to use the reduction formula. You can make use of this and this. So that will then take you. If you use this and this, it would take you to here. It would take you to here. But I'm just going to use the reduction formula. So using the reduction formula, our Rn here is 2. So it's saying 1 over 2. That's this thing here, and then 2 take away 1, that will be 1, and then 2 take away 1, that will be 1. This here will be 2. So 2 take away 2 would be 0. So cos x to the power of 0 will be 1. So that's this one here. And then now you can integrate this. So integrate it will then give you this. So from here, using the reduction formula will take you to here. And by the way, you can use these two. You can use these two instead of the reduction formula. So that will then take us to here. But here the answer is in terms of theta. We don't want the answer in terms of theta. We want it in terms of x. So we need to translate everything back into x. So looking at this, cos theta, well, this is cos here. Cos theta is this thing over 1. It's this thing over 1, which is just that thing. So this block here will then become this. Now we need to translate sine. Well, sine is just simply x. Sine is just simply x. And then theta, well, looking at this, sine theta equals x over 1. If you want theta, which we do here, if you want theta, then theta equals inverse sine of x. So that will then give us this thing here. So now, so this is the integral. So when you integrate it, it will then give you this. But we want it from 0 to a, because we want it, we want it from, bear with me, we want it from 0 to a. That will then give us this whole area. Okay, so hang on. So let me just jump down here. So we are currently, so when you integrate this, it will then give you this. But we want it from 0 to a. So that will then give us this thing here. Now put a into here, put a into here, put a into here. That will then give you this thing here. And then take away. Now take away. Now put 0 into here, put 0 into here, put 0 into here. It will be 0. So this whole thing here will then become this thing here. Okay, so this is our final answer. The area of this from 0 to a is given by this thing here. So now let's use high school mathematics in order to get to the same place. we can just use high school mathematics to get to the same place. So using high school mathematics, before we do that, if I were to give you a circle like this, and let's say this here is, let's say this here is 23 degrees. To work out the area of this, let's say the radiuses are, to work out the area of this, you would work out the area of the whole circle, pi r squared, cut up into 360 equal pieces. You would cut up into 360 equal pieces, and then you would times 23 pieces. So this thing here will represent the area of this. Okay, so we're going to use the same technique here. We want to find out this whole area from 0 to A, So we are going to split up right here. Let's split up. So A is here. You draw a straight line up. So split it up from here to here. The minute we know this angle here, then we can work out the area of this by working out the area of the whole circle, and then cut up into 2 pi equal pieces, and then times theta. Now, by the way, now we're working radians. Okay, the early example, when I said 23, when I said cut up into 23, cut up and then get 23 pieces, we were working degrees, but now we're working radians. So hang on, let's start again. We want to find out this whole area here. So the minute we know this area, then the minute we know this angle, then we can work out the area. So let's work out the angle here. Well, if from here to here is A, then from here to here is also A. So now we can work out the angle. Remember, the radius of a circle is 1, so the hypotenuse is 1. So now this is sine. So to work out the angle, it would be sine the angle theta equals opposite over hypotenuse, opposite over hypotenuse, which is just A. So theta equals inverse sine of A. So now that we know the angle, we can work out this whole area. So just work out the whole area of the circle, pi r squared. That will give you the whole circle. Cut up into 2 pi equal pieces, and then times your angle, sine inverse sine of A. Now the radius of a circle is 1. So the radius of a circle is 1. So this thing here is just 1, and pi here cancels out, giving you a half inverse sine of A. So the area of this thing here is given by this thing here, which, by the way, is this block here. It's this block here. Oh, sorry, it's this block here. So this thing here is that block. So this thing here is this block here. So it turns out that this area turns out to be this. So let's try and work out this area now. So from here to here is A. So to work out this area, we need to know the height. Well, the hypotenuse is 1. The adjacent here is A. So the height here will be 1 minus A squared. And then you see, so to work out this area, you would get this times this, which would be A root 1 minus A squared, and then that will then give you the rectangle cut in half. So divided by 2. So the area of this thing here is given by this, and this, by the way, is this thing here. So the two methods correlate with each other. Okay.